Welcome all. Let us see that compile design. Ninth topic we called as code optimization. Here the requirements are meaning must be preserved. When you are doing automation, the meaning should not, the program meaning should not be changed. Speed up must be occur on average. Work done must be worth the effort. These are the important things you have to consider when you are doing code optimization. The opportunities are the programmer, intermediate code, target code. This is the thing where you have to optimize. Code automation includes, listen here, the first phase is called lexical analyzer, the second phase is called syntax analyzer, the third one is called intermediate code generator. After the intermediate code generator, you are doing code optimization. So maximum how much as possible without changing logic, you can optimize. When you're doing optimization, the memory space will be reduced, speed will be increased. So these are the main purposes of using for code automation. The final phase of the compiler design is called as a code generator. The code generator will produce a target code. Meanwhile, all the symbols, variables are collected and stored in the symbol table. Levels, window, which is automation levels, window, people automation, basic block automation, procedural global control automation, program level automation. So these are the different level of automatizations. So I'll first see as the people automation, constant folding. For example, see that x equal to 32, x plus 32, it becomes 64. We can directly write x equals 64. This is called constant folding. Unreachable code. Go to L2, where L2 is not available in the code. This is unreachable code. Flow of control optimization. Go to L1, again becomes go to L1, again you are doing go to L2. It's not necessary. Two times you are doing jump. So it is a flow of control automation. You can use here, go to directly L2. Directly without going unnecessary another into loop, you can directly jump where you need it. So this is called a flow control optimization. People automation, algebraic simplification. X equal to x plus 0. There is no meaning for when adding 0. X equals same value. Without changing the value, now you have to doing algebraic simplification. It's called algebraic simplification. Debt code. X equal to 32, where x is not used after the statement. We may remove the x. It's a debt code. Y equal to x plus 1. Or y equal to y plus 32. Here the x is not necessary. We can remove that statement. This is called as a dead code. Reduction in strength, x equal to x plus x into 2. So the multiplication operator is costlier than addition operator. So x will be replaced by x plus x. That you can do is also called one of the people automation. Basic block levels, common sub-external elimination, constant propagation, dead code elimination, plus many others such as copy propagation, value numbering, partial redundancy elimination. These are the different basic block levels. Simple example, A of I plus 1 equal to B of I plus 1. Here see the code, common segment. A equal T1 equal to I plus 1, T2 equal to B of T1, T3 equal to I plus 1, again A of T3 equal to T2. They are adding like this. The second one, Ti plus 1 equal to T1, is B of T1 is a T1 here or assigned to T2. So T3 equal to I plus 1, again I will be no longer leave. So T2 assigned to A1. So this where you need the common subtraction should be eliminated. No, now suppose the constant folding I equal to 4, T1 equal to I plus 1, T1 equal to I plus 1, T2 equal to B of T1, T2 equal to B of T1, A of T1 equal to T2, A equal to 4, T1 equal to 5, T2 equal to B of T1, A of T equal to T2. So this is the final code. T4 equal I equal to P4, T2 we can remove this input constant I equal to I plus 1, T2 directly B of I. The I equal to I plus 1 is getting high, so I can directly B of I. A of I equal to T2 assigned to A of I, T1 equal to A of I directly. So it is called the constant folding. Flow control graph. So context equals vertices, edges, and entry, where P equal to vertices are nodes. E equal to edges, V into V. So potential flow control. Entry in as an element of the V as a unique program. Two sets used to an algorithm successive and prosective. So exits for the which are this 1 and 2 is a successive. So predictive is called as a 1. So like that, the flow of control, how would the control will flow one node to another flow node, which is explained the flow control graph. Definition point. Any location between the adjacent statement and before and after the basic block. A path in a context-free grammar from the point P1 to Pn is a sequence of points such that V of V come on I equal to 1 less than equal to j less than n. Either Pa is the point immediately preceding a statement and Pa plus 1 is the point immediately following a statement in the same block. Or Pa is the end of the same block and Pa plus 1 is the start of the successor block. Optimization on CFG must take control flow into account, common suppression elimination, constant propagation, dead code elimination, partial redundancy elimination. Applying one automation may create opportunity for the other things. Redundant expressions. An expression X operator Y is a redundant at a point of P if it has already been computed at the same point and no intervening operations define X or Y. M equal to 2 into Y into Z. N equal to 3 into Y into Z. Y equal to 2 into Y. So redundant, 2 into Y will be redundant again here. This and this plus redundant. So this will be eliminated by using this operation. Finally, T0 equal to 2 into Y, M equal to T0 into Z, T1 equal to 3 into Y. So no redundant operation is here. That can eliminate. So you can call this example. This is A plus B definition site. This is the definitions. Since A plus B is available there, redundant is not necessary. This is a redundant here. So that can avoid. So this can be A plus B is only one time, A into C, C D into D, into. So this can be right expression after redundant code will be removed. Redundant expression definition site, kill site. A plus B, C equals C into 2. If C greater than equal, this is not available, not redundant. This is the site where you will call not repeated any redundant expression here. So redundant will be avoided. Redundant expression. Expression P is defined at some point of P in the CFG if it is value is computed at P. An expression E is killed at point of P, the context grammar, if one or more of its operands is defined at P. An expression is available at a point P in the context-free grammar if every path leading to P contains a clear definition of E and E is not filled between that definition and P. Removing redundant expression similarly, T1 equal to A plus B, C equal to T1, D equal to A plus C. Similarly, again T1 assigned to Fi. So after removing all the redundant operations, we can use this expression A plus B. Okay, so the finally G equal to A and C, G equal to D and D, I equal to I plus 1. If I greater than equal, this loop will go and go back as well. Removing redundant expression. Constant propagation. See that B equal to 5, C equal to 4 into B. If C greater than B, if it is true goes this way, if it's false goes this way, where D equal to B plus 2, B and D is 5. So it's a 5 plus 2, take a time to express this value. It could again go for here. So instead of that, we can give directly D equal to 7. So you can directly go for this. This is a constant folding. Constant folding, another example. Directly if the D equals 7, go for directly for here. So B equal to 5, C equal to 20, D equal to 7, E equal to A plus 5. Directly you can go in for this. Copy propagation. B equal to A, again A, C equal to 4 into B, again C greater than B, D equal to B plus 2, E equal to A plus B. Again, if you are doing like this, B equal to A, C equal to 4 into A, C equal to C greater than equal to A, we just go for D equal to A plus A. So the copy propagation takes time. So instead of this, again and again doing the same thing, it will avoid of using copy propagation. Doing only one time copy, later on you are using this whenever needed. Simple loop automation code motion. You see that loop while I less than equal to limit minus 2. So this will be executed every time the limit minus 2 will be executed. So instead of this, the code will be moving out of the loop. T equal to limit minus 2 while I less than equal to. So the limit minus 2 will be moving out of the loop. So you can avoid for repeating many times. So it is called loop optimization. Simple loop optimization that will explain that j equal to j minus 1, t4 equal to 4 into j. The t4 equal to 4 into j will move out of the loop. Okay, we do it with calculation only one time. Remaining time is need not do for the again the same thing repeated many times. So that will be avoided. That simplification is called a loop optimization. Simple loop automation. Loop transformations are often used to expose other automation opportunities: normalization, loop interchange, loop fusion, loop reversal. Data dependency, flow dependency rated. If x equal to 4, y equal to x plus 1 is a flow dependency. Output dependency, x equal to 4, x equal to y plus 1 is output dependency. So anti-dependency, y equal to x plus 1, x equal to 4 is anti-dependency. Global data flow analysis, collecting information about the way data is used in the program, takes control flow into account. High-level language controls construct simpler syntax there, useful for data flow analysis of the source code. General controls constructs arbitrary branching, information needed for automation such as constant propagation, common subexpression elimination, partial redundancy elimination. Data flow analysis iterative techniques. First, compute local information iterative until no changes, while and change equal to false. For each basic block, applying equations, updating in and out. If either in or out changes, set change to true. Live variables. A variable x is live at the point P if there is a some path from the P to P where x is used. Therefore, it is called as a live. Want to determine for some variable x at point P where the value of x could be used along some path starting at P. Information flow backwards may along some path starting at P. Global live variable analysis. Want to determine for some variable x and point P where the value of x could be used along some path starting with P. Definition. Define set of variables assigned value in B prior to any use of that variable. Use B. Set of variables used in the B prior to any definition of the variable. Out B. Variables live immediately after the block. Out B. So like this, in B. Variables live immediately after the block in B equal to use B plus out B is the definition like this. This is a global live variable analysis. So this is explained here. This definition define A comma B. We are not using these variables here. We are using definition CD, but using AB is a global data. Here in this block, no definitions are defined, but we are using B and D. This is a global data process. Similarly, we are defining D using A, B, and E. Is also called different blocks, but using the previous defined variables. So it's called global variables. Similarly, here also using